Here we're given a graph with lots of jumps and holes in it, and we're asked to find all the points where the function is discontinuous and to explain why. Take a look at this graph. We have this big jump at x equals 1. We have a hole at x equals 3. We have a vertical asymptote at x equals 4. And at x equals 5, we have another hole. And what I forgot to draw, which I'll draw in a moment, is a little point at x equals 5, but it's not in that open gap, it's elsewhere. All right, so let's find the discontinuities. Let's list them and let's explain why the graph is discontinuous there. So in the first column, we'll have the discontinuities at, and the second column will explain why. The first discontinuity occurs at x equals 1 because, well, the left limit, in other words, the y partner as x approaches 1 from the left, is equal to -2. But the right limit as we approach x equal 1 from the right side is 1. That implies the left limit is not equal to the right limit, and that implies the limit as x approaches 1 of the function does not exist. And that's the reason we have discontinuity at the point x equals 1. Next point of discontinuity is x equals 3. Look at the graph at x equals 3. It has a hole. The left limit is 4, and that equals the right limit. So it actually is true in this case that the limit as x approaches 3 of the function is equal to 4. However, the function evaluated at 3, the y partner to x equals 3, is undefined, and that is enough reason for the discontinuity at x equals 3. The next location on the graph that we're looking at is x equals 4. That's a discontinuity, and here's why. Well, you can see on the graph we have a vertical asymptote. The limit from the left is infinity. The limit from the right is also infinity, and that implies a limit as x approaches this 4 of the function is equal to infinity. But what does it mean for a function to equal infinity? It means it doesn't exist because infinity is not a real number. The limit does not exist. If the limit does not exist, we have a point of discontinuity at that x value, x equals 4. And finally, look at the value x equals 5. There's that gap, that hole, and we actually have the function defined with a single point at y equals 2, which I had forgotten to draw. So x equals 5 has a discontinuity there, and that's because the left limit is equal to 4, and that's also equal to the right limit. So both from the left and the right, the y partners as we approach x equal 5 are approaching 4. Limit as x approaches 5 is equal to 4. However, the limit as x approaches 5 is not equal to f of 5. And that is a requirement if we want continuity at that point x equals 5. So this is enough to say that since f of 5 is equal to 2 instead of that 4, we have a point of discontinuity at x equals 5. Now let's extend the screen and look at the names of these discontinuities. Discontinuity name, and how do we define these types of discontinuities, and which of the examples here have these types of discontinuities. The first type of discontinuity is called a jump discontinuity, and you can see from the graph what it's talking about here. It happens, it's defined by the left limit and the right limit equaling a finite real number, but they're not equal to each other. The left limit does not equal the right limit. That causes a jump in the graph. And that's the example we saw when x was equal to 1 on the graph. That was a jump discontinuity. The next type of discontinuity is called a removable discontinuity. It's called removable because if you just define the graph at that x value as a single point somewhere on the plane, you could remove that discontinuity. And it's defined by the left and right limits being finite real numbers, but the function evaluated at the number a is not equal to that limit. So the y partner to a doesn't give you the same as the limit. And that occurred in this graph at x equals 3 and x equals 5. And the last type of discontinuity is called an infinite discontinuity, and it is defined by the left limit and or the right limit not existing. Okay, so when either the left or the right limit does not exist, or both of them, that indicates that you have an infinite discontinuity, and in this graph that occurred when x was equal to 4.